Hey guys, so today we are doing lesson 9 for module 8. So you have a do now question, which is on ice cream sales versus noon temperatures. Now you guys already kind of done this for a project that I've given you a while back. So we're bringing this back. So I actually want to give you time to answer the first 3 parts. So 1, 2, and 3. So go ahead and take about 5 minutes and do 1, 2, and 3. And we will come back together. All right. So let's go ahead and do this together. I'm going to go ahead and start entering the data. And if you are still entering the data, that is okay. But make sure you are following me for step 1 and I'm sorry, for step 2 and step 3. So I'm actually doing this part. So 16.4, 325, okay, 11.9, 185, 15.2, 332, 18.5, 406, 22.1, 522, 19.4, 4, and then 412, and then 25.1, then 614, 23.4, and 544, 18.1, 421, 22.6, 445, 17.2, and 408. Okay, so now that we have this table, I'm going to go ahead and make my graph. Remember, we want to highlight all the numbers. So highlight, and then we want to go ahead and choose. I'm going to choose the insert chart right here. This is the icon. If not, you know where to go to do the scatter plot. Okay, so here, oh, and guys, I forgot to label. So we need to make sure we label because it says y versus, whoops, there we go, y versus x. So we want to make sure we're labeling that. So x was temperature, and then y is ice cream cells. Cells. Okay, so I'm going to go ahead and delete this chart and make the chart again so that way it has the right title. Highlight, insert chart. Okay, there we go. Okay, so you should automatically know already just by looking at this chart. It has what kind of trend? A positive linear, negative linear, or no trend? Correct. It has a positive linear trend, meaning as the temperature increases, the ice cream sales increases. Okay, and that's it for part 3. Okay, so you're going to start getting in the habit of this as we're doing these examples and practices today. So number 4, is there a causal relationship between the two variables? Now this is something we have not learned yet. Causal we're about to talk about. When I say causal relationship, I'm referring to like, is there a cause and effect? So I want you to think here for a minute. So you know how I was asking about reasonable for the past couple of lessons? So now what's going to happen whenever we're looking at data is they're going to actually start asking if there's a causal relationship. Is there a cause and effect between the two? So basically, is temperature making an effect on ice cream sales? And the answer would be yes, because think about it. Like when it is hot outside, people are more likely to crave ice cream because it's hot. They want something to cool them down. versus like if you were to probably put winter like degrees, because remember these temperatures are in Celsius, so this is like pretty hot for Celsius. Now if these numbers were lower, that means it's winter time and people probably wouldn't crave as much ice cream. Okay, so the ice cream sales would be going down a bit. Okay, because it's colder outside. People are most likely craving something hot to cool, to like not cool, to basically warm up. Okay, so there is a cause and effect here. So this would actually be a causal relationship. Okay, because temperature has a has an effect on ice cream sales. When it's hot outside, people want to eat something to cool them down. Okay, so that would be a causal relationship. Okay, so let's actually go into that. So what is a causal relationship? A causal relationship is a cause and effect between two variables. Okay, and again, it goes back to the ice cream sales versus temperature. That's the perfect example to tell you what a causal relationship is. A non-causal relationship is when there is a trend. Okay, there is a trend still. But the two variables do not have a cause and effect. Okay, so the example I'm using here for a non-causal relationship is that, look, at shoe size and reading scores, yes, there's a trend, there's a relationship basically, but they do not have a cause and effect. We cannot say your shoe size is going to affect your reading score, because you have to think about it. It's like going back to my mom again. Like, my mom is a size shoe 7. Her size 7 could probably be right here, right? So that's saying that she's going to have a low reading score, when in fact she's a grown adult and she has a very high reading score. So we need to think about those types of things when it comes to that. So that's when we're analyzing data. You have to be really good at critical thinking of like, is this possible? Okay, so that is a non-causal relationship. So this would be a good example. Another one is like with like study time and math scores. That's a non-causal relationship because yes, it's kind of like your study time does kind of affect your math grades. It does. Yes, you can say that, but then it goes into that argument of like, well, I can study for 2 hours and still get a good grade. So it goes into that play again. So that's why a lot of people, like, you'll see it's a controversial issue with study time and like, you know, your grades in school, because a lot of people can say that's a causal relationship and a lot of people can say that's a non-causal relationship. But just to be clear what a causal and a non-causal is. So let's go ahead and go into the work today. So lesson 9, line of best fit. So basically, guys, what you're going to be doing is you're going to be using your graphing calculator a lot. We're going to be using STAT. If you are using your graphing calculator, I am going to actually be using Desmos just to expose you of like the different ways of doing things, okay? So there are 3 parts. So the table below gives the number of hours spent studying for science exam and the final exam grade, okay? So here, for part A, we have to make the scatter plot. So let's go ahead and highlight my data, make that scatter plot, okay? Now it's grades versus study hours. Okay, wow. We can already tell that is a positive trend. So I'm going to go ahead and put my graph right here. I'm making it small so my work's concise. Okay, so it looks nice and neat. Now I'm going to show you how to make that equation, which most of you probably already are familiar with. okay? But this is just step one. Later on, I'm going to have to show you whenever there's a lot of data, okay? So let's go ahead. Oh, sorry, guys. Let's go ahead and go to Desmos, okay? We want to go ahead and insert a table. We're going to have to insert a table by putting it by hand. So we're going to go ahead and go 277, okay? Then 5, then 92, whoops, and then 170, okay, 0, 63, 4, 90, okay, 2, 75, 384. Okay, so this would be your table. Now you're making line of best fit. Now what you're going to have to do is do a linear equation. So the linear equation you want to do is y equals mx plus b. So again, this kind of goes back to what we did for our fluency last week, or like last lesson. So go ahead and put y1, because we're looking at y1 here, the outputs, equals mx1 plus b. Okay? Should do it. Let's see. Oh, sorry, you can't put equals. You got to put the little squiggly line, because it's an estimate. You're finding that line, the line of best fit. Okay? So here, let me like zoom out here so you can actually see the graph. So here is where you're going to see that line. So this right here, guys, this line is an estimate. This is line of best fit. So like whenever you're doing this in your, I'm going to zoom in a little bit more so you can see what I'm talking about. So like whenever, like, you know how I was telling you to draw the line to analyze data? This is exactly what you're doing on Desmos. Okay, that's why I'm using Desmos, so you can see that, because on the graphing calculator, we can't see that line of best fit really. On here you can. So you can see the points are getting close to that line. That means it's line of best fit. It's estimating it for you. So here, your equation for for part B, let's go ahead and I'm going to move this screen. Okay. And let's go ahead and write our line of best fit. Okay, move this here. Okay, so my equation would be y equals, okay. Now I want to estimate here to the nearest tenths place. So it would be y equals 6.1 x plus 63.9. Okay? That is your equation. That is your line of best fit. Okay? So just to show you, that would be your line of best fit. Okay? Now, part 3, now they're doing a little bit more here. Now you have to predict the exam grade of a student who studied for 6 hours. Now remember, X represents the hour study, Y represents this grade. So we're saying this equation is going to help us find out, like basically predict of what that student's grade would be if they studied 6 hours, if we are following this scatter plot. Okay, so it would be, I'm going to go back to Desmos here. Okay, so it would be it would be 6.1 parentheses and then how many hours? Because 6 is going to represent the X. It would be 6 parentheses plus 63.9, which means this student would have made 100.5. But think about it here. Can you make 100.5 on a grade? No. So you want to give that estimate. So it would be 100. You would technically get 100 on that assignment. So what I want to do is I want to give you time to do questions 2 and 3. I want you to try doing those on your own. And then we're going to go into practice number 1. Okay, so do number 2 and number 3. Give you 5 minutes. All right. So now let's go ahead and go into the real world situations here. So here it has a table shown below, the mean temperature in July and the mean amount of rainfall per 14 cities in the Midwest. Okay, so again, we are doing all parts. So part A, B, and C are just like what you did here for these examples here. Okay, so let's go ahead and do that. So what we're going to have to do for part A is make the scatter plot. So let's go ahead and make that scatter plot. So highlight, okay, make my charts, okay. Now we have a chart. Now I would actually make this big because this is real data that you do need to see. So I would want to make it big so that way you can look at it, okay. So I'm going to put it right here in the bottom, okay. So it's kind of making a positive trend. Like there's some clusters and there's a few outliers, right? Okay. So it's telling you what is the equation of the line of best fit. So let's go to Desmos. Okay, let's go here. And we're going to have to do this all by hand. And this is normal, so don't freak out if like you have to do this a couple of times. So I'm going to be doing this with you. So type as I'm going, okay? So X1, which is it's July, and then the rainfall will be Y. So 73.3, then 36.27, okay, 71.9, okay, then 38.71, okay, 75.1, and then 38.52, okay, then 76.1, 34.72, 73.5, 32.89, okay, 65.5, 31. Oh, whoops. Hey, there we go. All right, and then 71.4, 37.13. We're halfway there now. And then 75.4, 40.95. Make sure you're doing it. 71.6, 32.95, 72, then 34.81, then 73.2, and then 29.41, 76.3, 35.56, 80.2, and 38.75. Last one. Okay. 73 and then 33.21. Okay. So now we have all of those. So let's go ahead and find the line of best fit. So it would be Y1, because remember we're still working with this one, Y1. That little squiggly line, so shift, then MX1 plus B. Okay, so our line of best fit, and let's actually look at this. Come on, where are you? There we go. Okay, this would be our line of best fit, and I think it's going to be mostly over here, guys. Yeah. Okay, so do we see where all these points are at? So they're kind of close to this line. This is the best that we can do. We can't really move the line. But this is where all the points are close to, okay? So now, for our equation, we want to make sure we're estimating to the 10th place. So it's going to be y equals, m is 0.49, so we want to make it 0.5, remember, to the 10th place, x, plus b, which is negative 1.249, so to the 10th place, so it would be not even plus now, it's going to be minus 1.2. Remember, to the 10th place. Okay, so this would be our equation. And I'm going to highlight that and bold it so you can see it. Okay, So now they're asking if the mean temperature in Dury, Maryland is 81.5, what would be the predicted rainfall, the predicted mean rainfall? So let's actually find that here. So now we're going to have to find that. So it's going to be 0.5 parentheses, and then what was the temperature? 81.5. Okay, so 81.5 parentheses, then minus 1.2. Okay, so that means the predicted rainfall or predicted mean rainfall would be 39.55. You just put it just like that. Okay, I'm going to bold it. And then I want you to think here. So looking at the graph, looking at the data, is this a causal relationship? I want you to think about this. We're looking, is the temperature affect the rainfall? It possibly could, right? That could be a causal relationship. Like, think about it here in Houston. Like, in the summertime, and especially around in the August and September months, that's hurricane season. And that's because there's more moisture in the air, right? When it gets hot and humid here, there's going to be more moisture in the air, and we're most likely to have that rain. So it is a causal relationship. So there is a cause and effect here. So I would put there's a causal relationship between both variables because temperature does affect rainfall. And if you notice too, guys, this is Midwest. So Midwest, they're kind of dry up there sometimes. So it only has rainfall during certain months of the year. So it makes sense when there's moisture in the air. Okay? All right. So what I want you to do is I want you to do practice 2. So this is the next one you need to do practice on. Now the last thing you are going to do is the exit ticket. Make sure you upload the exit ticket into the Google form, okay? And please let me know if you have any questions, guys. All right.